All right, today we're going to be talking about data organization and some displays and kind of start thinking about analysis. How do we analyze data? But the first step when you've got data is to collect it. And once you have data, then you probably need to organize it. And so we're going to talk about a way to organize data in this video, and that way is a stem and leaf plot. So I copied this math notes from your textbook. I thought we'd just go over that together. So a stem and leaf plot is a way to display data that shows the individual values from a set of data and how the values are distributed. The stem part of the graph represents all of the digits in a number except the last one. So this is our stem area, everything on the left side of this line. And it represents all of the digits in a number except the last one. Another way to say this is that it represents the number of tens. So if I had 49 as a number, a piece of data, then 40 or 4 represents the number of tens, which is the equivalent of 40. So we can kind of think about this stem as the number of tens. And even if I had a piece of data that was like 102, I would have 10 tens and 2 ones making up 102. So thinking of it as the number of tens is another way to think about it. The leaf part of the graph represents the last digit of each number, or the ones number of ones in the ones place. An example is students in a math class received the following scores on their tests: 49, 52, 54, 58, 61, 61, 67, 68, 72, 73, 73, 73, 78, 82, and 83. And you'll see they've already sort of organized their data. They've organized it from least to greatest, and that's a helpful step when making a stem and leaf plot, but not entirely necessary. I'll show you a way down below when your data isn't organized to still make a pretty organized stem and leaf plot. And so they've displayed the test score data on a stem and leaf plot here. And when we look at this, we can already see some of the advantages of the stem and leaf plot over this organized list. We can quickly identify the interval that has the most data. Like most of the kids scored in the 70s on this test. 2 of the kids scored in the 80s. 1 kid is not in a good place here. He's got 49. But 4 kids are in an area of kind of concern. If you were a teacher, you would think like 4 of the kids have got some work that we need to work on, some skills to work on. So anyways, this key is helpful because it shows us that how we read this is 8 representing 8 tens and 2 representing 2 ones gives us the data point 82. And you'll see they leave space on the one side between the next data point, so it's not confused as 23 or 823. That space reminds us it's a new set of data, and that's 8 and 3 combined to make the data point 83. So this is kind of an overview of how to read stem and leaf plots. But let's go ahead and just make our own here. So a stem and leaf plot shows all the values in a data set and how the values are distributed. This is kind of a silly blank here. A stem and leaf plot shows all the values in a data set and how they're distributed. So this is a set of data: 36, 30, 35, 32, 30, 31, and 38. And this is another set of data. And I'm wondering which of these sets of data would be a better set to use the stem and leaf plot for. I want you to take a minute to think about which set of data you would choose to organize with a stem and leaf plot and why. If you chose this set of data, I agree with you. When we have data that's really close in range, meaning we don't have very many numbers from our least to the greatest, this set of data has a minimum of 30 and a maximum of 38, meaning our range is really small. There's only like 8 to 9 numbers here that we are going to organize. And so a stem and leaf plot doesn't give us much advantage since they'd all be in a stem of 3, and I'd basically have no other numbers in the 20s or the 40s. It's not going to be a very interesting stem and leaf plot. So if you chose this set of data, let's go ahead and copy that down here. 65, 48, 52, 72, 60, 59, 55, 45, and 80. This set of data has a wider range, and so we want to think about, well, what's the range? Our minimum is 45, so we're going to have to set up our minimum part of the stem will have 4 tens, and our maximum piece of data is 80. So min and max are kind of important points to identify. So we're going to make this stem and leaf plot cover all of the numbers from 40 to 80. Now, if our highest was 110, then I'd want to go all the way down to 110, even if I don't have data in the 90s. We're not going to skip tens just because it's important if there is a big gap between data points. So then I'm going to start to identify my least to greatest in each row, because we do want this to be a pretty organized list. And it's better if we have our smallest 40s and then our biggest 40s over here at the edge. So 45 is my smallest, so I'm going to put a 5 here. And then I think it's good to circle or underline data points as you use them. So I'll just go ahead and circle them. I'm going to leave that space and show 8. And I'm going to try to keep my spacing even so it's also easy to tell which row has the most data points in it. And let's see, then in the 50s, I think I got all the 40s, 52 and 55 and 59. So 52, 55, and 59. And then 60s, I have 60 and 65. And 72, the only 70s, and then 80. So that's how you can make a stem and leaf plot. I do recommend marking off your data. You could cross it out, but I like to see the data still. And then we can double check. The way that we can double check that we've got all of the data points is by counting the leaves side and making sure that it meets the number of data points that we have. So I know I have 9 data points. So I should have 9 leaves. 1, 2, 3, 4, 5, 6, 7, 8, 9. And once I know that those match up, then I am convinced that I've organized all of my data. Hopefully this was helpful.